2 hours, 4 minutes, 32 seconds, and counting.
We're also committed to mission success, that we are just ready to take those little inconveniences.
For more than 50 years, the moon has held one question that scientists still struggle to answer: what comes next? We've walked on it, we've studied it, but what humanity is planning now is unlike anything ever attempted before. Because the next time we return to the moon, we're not just visiting, we're going to stay, and what lies ahead is nothing short of revolutionary. Stay with me till the end, because what we uncover in this documentary will change the way you see the future of humanity. Before we explore the journey from Apollo to Artemis and beyond, make sure to subscribe, because the story of our return to the moon is unfolding right now, and you don't want to miss it. For over half a century, the moon has captivated humanity's imagination. From the first steps taken by Neil Armstrong in 1969 to the ambitious plans for sustainable lunar habitation today, the moon represents both a historical milestone and a gateway to the future. Across decades, technology, vision, and international cooperation have evolved, turning what was once a dream into a platform for scientific discovery and the next giant leap for humanity. Today, commercial companies, government space agencies, and global partners are preparing to push lunar exploration to unprecedented levels, transforming the moon from a distant celestial body into a hub for science, industry, and human expansion. Before diving into the history and future of lunar missions, subscribe now to follow the unfolding story of humanity's return to the moon and beyond. Apollo missions, humanity's first steps on the moon. The Apollo program remains the most iconic chapter in lunar exploration. Between 1969 and 1972, NASA's Apollo missions achieved 6 successful moon landings, sending 12 astronauts to explore the lunar surface. Apollo 11, led by Neil Armstrong and Buzz Aldrin, marked humanity's first steps on the moon, a moment watched by millions worldwide. Subsequent missions, including Apollo 12, 14, 15, 16, and 17, expanded our understanding of lunar geology, conducted experiments, collected rock and soil samples, and deployed instruments that provided data for decades. Apollo showcased human ingenuity, technological mastery, and the power of a global vision, setting the foundation for all future lunar exploration. Technological innovations of Apollo. Apollo missions relied on groundbreaking technology, including the Saturn V rocket, the most powerful rocket ever built, capable of delivering astronauts and equipment to lunar orbit. The Lunar Module, designed for precise landings, allowed astronauts to explore diverse terrains. Onboard guidance systems, communication networks, and life support technology ensured safety during lunar descent and surface operations. Scientific instruments, from seismometers to magnetometers, provided humanity with the first comprehensive understanding of the moon's structure. These innovations not only enabled Apollo, but laid the groundwork for decades of lunar and space technology development. The gap between Apollo and modern exploration. After Apollo 17 in 1972, human lunar exploration paused for decades. The moon remained a focus for robotic missions and scientific study, but humans did not return. This hiatus allowed technology to advance, international cooperation to grow, and private industry to enter the space sector. Now, renewed interest in the moon is driving a new era of exploration, combining lessons from Apollo with cutting-edge technology, commercial innovation, and global collaboration. Artemis program, NASA's return to the moon. NASA's Artemis program marks the next chapter of lunar exploration. Unlike Apollo, Artemis focuses on sustainable, long-term human presence. With missions like Artemis V, uncrewed, Artemis II, crewed lunar flyby, and Artemis III, crewed lunar landing, NASA is returning astronauts to the moon, including the first woman and the next man. Artemis integrates new technology from the Space Launch System, SLS, to Orion spacecraft life support systems, modular habitats, and autonomous robotics. Its long-term goal is to establish infrastructure that supports extended stays, scientific research, and preparation for human missions to Mars. Commercial lunar missions. Private companies are now playing a pivotal role in lunar exploration. Blue Origin's Blue Moon lunar lander aims to transport cargo and humans to the moon, providing infrastructure for NASA and international partners. SpaceX is developing Starship for lunar cargo and crew transport, with capabilities to support Artemis and other commercial missions. Companies are also developing lunar rovers, habitats, and in situ resource utilization technologies to enable sustainable lunar operations. These commercial ventures accelerate innovation, reduce costs, and expand the possibilities for human activity on the Moon. International lunar collaboration. The Moon is no longer the domain of a single nation. Agencies such as ESA, Europe, JAXA, Japan, Roscosmos, Russia, CNSA, China, and ISRO, India, are contributing to lunar science, transportation, and technology development. As we move deeper into the new era of lunar exploration, one thing becomes clear. The Moon isn't just a destination, it's a launch pad for the future. From robotic landers to commercial spacecraft and international partnerships, every mission adds a new piece to the puzzle. But the real question is, can humanity truly build a sustainable presence on the lunar surface? We're testing technologies that Apollo astronauts could only dream of. Autonomous construction, ISRU, fuel production, 3D printed habitats, and long-duration life support systems. And before we continue, be sure to comment your thoughts below. Do you think humans will be living on the Moon within the next decade? I'd love to hear your opinion. Collaborative projects include lunar orbit stations, shared research initiatives, and joint missions. By pooling resources, knowledge, and technology, these international partnerships enhance safety, reduce cost, and promote the idea that the Moon belongs to all of humanity. This global cooperation mirrors the complexity of the challenges faced in sustaining human presence beyond Earth. Scientific objectives of modern missions. Modern lunar missions aim to achieve far more than setting foot on the Moon. Scientific objectives include mapping lunar resources, studying water ice deposits in permanently shadowed craters, analysing regolith for future construction, and testing technologies for life support and energy. Experiments in astronomy, human physiology, and planetary geology will provide invaluable insights, not only for lunar settlement, but for long-duration missions to Mars and beyond. The Moon becomes a laboratory for humanity's next steps in space exploration. Sustainable lunar habitation. Future missions prioritize sustainability. Lunar habitats are modular, designed for extended stays with life support systems, radiation shielding, and energy production via solar arrays or nuclear power. Robotics and autonomous systems assist humans in construction, resource extraction, and maintenance. Water ice can be converted to oxygen and fuel, while 3D printing technology using lunar regolith may provide building materials. Sustainability ensures that humans can live, work, and conduct research on the Moon for months or even years, creating a foundation for permanent presence. Challenges of lunar exploration. Lunar exploration comes with immense challenges. Extreme temperatures, high radiation levels, abrasive dust, and communication delays pose risks to both humans and technology. Precision landing, resource utilization, and long-duration life support are engineering and logistical hurdles. Mitigation strategies include redundancy, autonomous systems, robust testing, and incremental mission design. Each challenge drives innovation and ensures that future lunar settlements are safe, efficient, and resilient. Inspiration and education. Moon missions inspire generations. From Apollo's historic first steps to Artemis and commercial lunar endeavours, these missions captivate the public imagination. Education programs, media coverage, and interactive experiences showcase the science, engineering, and human courage involved. They motivate students, engineers, and scientists to pursue careers in space, ensuring a pipeline of talent to continue humanity's journey beyond Earth. The future, gateway to Mars and beyond. The Moon is the first step toward interplanetary exploration. Lessons learned from Artemis, commercial missions, and international collaboration will inform human missions to Mars. Infrastructure on the Moon, including habitats, energy systems, and robotics, serves as a testbed for technologies required for Mars. The Moon becomes a staging ground, a laboratory, and a proving ground for humanity's expansion into the solar system. Lunar technology and innovation. Modern Moon missions leverage cutting-edge technology that Apollo could only dream of. Advanced spacecraft, autonomous rovers, and precision landing systems allow astronauts and cargo to reach the Moon safely and efficiently. Life support systems now recycle air and water, providing sustainable habitats for months-long missions. Energy generation has evolved from simple solar panels to integrated solar arrays combined with nuclear options, ensuring uninterrupted power in permanently shadowed craters. Robotics, AI, and autonomous drones assist in exploration, construction, and resource utilization, reducing risk to humans while maximizing efficiency. Each technology tested on the Moon is a stepping stone for deep space missions, particularly Mars, where autonomy, reliability, and sustainability are paramount. In situ resource utilization, ISRU, future Moon missions focus heavily on using local resources, or ISRU, to sustain human presence. Water ice discovered in lunar polar craters can be converted into drinking water, oxygen, and hydrogen fuel. Lunar regolith, or soil, can be processed into building materials for habitats, landing pads, and radiation shielding. Utilizing local materials drastically reduces the need to transport everything from Earth, making missions more cost-effective and sustainable. ISRU technologies are tested through robotic missions and surface experiments, preparing for larger-scale operations that will support permanent settlements and eventual Mars expeditions. Lunar surface operations and exploration routes. Exploration planning has become far more sophisticated than during Apollo. Modern missions map routes that maximize scientific value while minimizing risk. Rovers carry astronauts across rugged terrain to collect samples, deploy instruments, and test new technologies. Autonomous drones survey hazardous areas, while robotic systems handle construction, cargo transport, and habitat assembly. The South Polar region is of particular interest for its water ice and near-constant sunlight, which enables energy generation and supports extended human activity. These operational strategies ensure that humans can explore safely, efficiently, and sustainably. Commercial lunar ventures. The private sector is now a major player in lunar exploration. Companies like Blue Origin, SpaceX, and other emerging startups are developing lunar landers, habitats, and cargo systems. Blue Origin's Blue Moon lander and SpaceX's Starship are designed to deliver heavy payloads and humans to the lunar surface, complementing NASA's Artemis missions. These commercial ventures accelerate innovation, lower costs, and expand access to space. They are not just partners, they are critical enablers of sustainable lunar operations and long-term exploration. International cooperation. The Moon is no longer an arena for a single nation. Space agencies from Europe, Asia, and beyond are contributing to lunar exploration. ESA provides modules and technology for orbital platforms. JAXA contributes robotics and habitat systems, while ISRO, CNSA, and Roscosmos develop landers, orbiters, and scientific instruments. Collaborative projects such as the Lunar Gateway, shared research missions, and joint scientific studies demonstrate that space exploration is a global endeavour. This cooperation reduces costs, increases safety, and fosters innovation through shared knowledge and technology. Challenges of long-duration lunar habitation. Living on the Moon is far from easy. Extreme temperature fluctuations, radiation exposure, abrasive dust, and the Moon's low gravity pose significant risks. Engineers address these challenges through robust habitat design, radiation shielding, and redundant life support systems. Protective suits, autonomous systems, and robotics reduce human exposure to hazards. Each mission incrementally tests the ability of humans to survive and operate on the Moon, providing vital data for future settlements on both the Moon and Mars. Lunar science and research. The Moon serves as a laboratory for humanity. Lunar missions study geology, water distribution, regolith composition, and the potential for mining and energy production. Human physiology is studied in low gravity, and life support technologies are tested in real conditions. Astronomy experiments take advantage of the Moon's stable platform and thin exosphere. Data collected will guide Mars missions and deeper space exploration, ensuring that humanity's return to the Moon is not only symbolic, but scientifically transformative. Preparing for Mars and deep space exploration. The Moon is humanity's proving ground for Mars. Lessons learned in habitats, energy systems, ISRU, and robotics inform the design of Martian missions. Technologies such as precision landing, autonomous cargo transport, life support recycling, and habitat assembly are first tested on the Moon. training astronauts in lunar environments prepares them for the physical, psychological, and operational challenges of interplanetary missions. The Moon acts as both a laboratory and a stepping stone, enabling humanity to expand safely into the solar system. Inspiration, education, and public engagement. Moon missions inspire generations. From the iconic Apollo footprints to Artemis and commercial lunar endeavours, the story of human space exploration captivates imaginations. Educational programs, media engagement, and interactive experiences allow the public to witness and participate in space exploration. By inspiring curiosity and providing tangible examples of human achievement, lunar missions cultivate future engineers, scientists, and explorers who will carry humanity even further into the cosmos. Vision for sustainable lunar colonies. Future lunar settlements will be permanent, modular, and sustainable. Habitats, energy systems, and life support modules will form interconnected bases. Resource extraction, ISRU, and robotics will support long-term human presence. The Moon will serve as a research hub, a commercial platform, and a launchpad for missions to Mars and beyond. International cooperation and commercial partnerships will ensure that these settlements are efficient, cost-effective, and globally supported. Challenges, risks, and contingency planning. Every lunar mission must contend with risk. Space radiation, meteor impacts, technical failures, and psychological strain are real threats. NASA, commercial companies, and international partners mitigate these risks through redundancy, extensive simulation, autonomous systems, and incremental mission design. Contingency plans include emergency shelters, redundant power, and communication systems. Each successful mission builds confidence, knowledge, and capability for long-duration lunar habitation. The Moon as a gateway to humanity's future. The Moon represents more than science or exploration. It is a symbol of human ambition. By establishing permanent settlements, advancing technology, and fostering international collaboration, the Moon becomes a gateway for humanity's expansion into the solar system. The knowledge, infrastructure, and experience gained from lunar missions will pave the way for Mars, asteroids, and beyond, ensuring that humanity's reach extends far beyond Earth. Outro Moon missions link our monumental past achievements with the promise of the future. From Apollo's historic landings to Artemis, commercial ventures, and international collaboration, the Moon is becoming a platform for science, exploration, and human expansion. Subscribe now, hit the bell icon, and follow every launch, every mission, and every milestone as humanity returns to the Moon and prepares for its next giant leap to Mars and beyond. The Moon is just the beginning, and the journey to the stars is now in motion. Moon missions link our past achievements with the promise of the future. From Apollo's historic landings to Artemis, commercial ventures, and international collaboration, the Moon is becoming a platform for science, exploration, and human expansion. Subscribe now, hit the bell icon, and follow every launch, every mission, and every milestone as humanity returns to the Moon and prepares for its next giant leap to Mars and beyond. The Moon is just the beginning, and the journey to the stars is now in motion.